Now today in this lecture I am going to solve the numericals of current electricity. So here question number 17, and these numericals are from the hit the target. Up to question number 16 already I have explained. Now you see from the 17. In a potentiometer circuit, the balancing length with the resistance of 2 ohm is found to be 100 centimeter. Means 2 ohm के corresponding balancing length is, here you can see, corresponding to 2 ohm balancing length is 100 centimeter. And you have to find the balancing length corresponding to the, you have to find the resistance when the balancing length is 500 centimeter. What will be the value of resistance when the balancing length is 500 centimeter? So there is one formula, R1 upon R2 equals to L1 upon L2. You substitute in this. So it will be equal to 2 upon R2 equals to L1 is what? 100 upon 500. This and this cancel. So what will you get? R2 equals to 5 2 ja 10 ohm. This will be the answer. Then question number 18. Calculate the net EMF across A and B. Across A and B, what will be the net EMF? So here you can see there are the two cells, each of 4 volt. They are connected in series. What will be their total EMF? So if they are connected in series, then it will be equal to the sum. So what will be this? E1 equals to 4 plus 4 equals to 8 volt. Now in the other parallel branch there is only 8 volt. Now this branch and this branch both are having EMF what? 8 volt. This is 8 volt, here also having EMF 8 volt. Now as you know that in parallel potential difference, EMF is basically a potential difference when cell is in the open circuit. So in parallel potential differences are not added. So what will be the net EMF between A and B? A and B, that will be equal to 8 volt. मीन्स हमको याद रखना है सीरीज में EMF पोटेंशियल डिफरेंस ऐड हो जाते हैं. पैरेलल में क्या होगा? जो एक ब्रांच के क्रॉस पोटेंशियल डिफरेंस होगा दैट विल बी द पोटेंशियल डिफरेंस, दैट विल बी द नेट पोटेंशियल डिफरेंस. Now obtain the balancing condition for the Wheatstone bridge as shown in the diagram. So that already I have explained in the lecture. So you have to simply solve this, derive this. P upon Q equals to R upon S. You will do its derivation. It's clear? So already we have done in the lectures of, in theory lectures. So obtaining the balancing condition. This is the balancing condition of Wheatstone bridge. It's clear? P upon Q equals to R upon S. When it will be this, then what will be the potential at this point and potential at this point will be same. These 2 points will have the same potential, and if you connect with the help of a wire, if you connect with the help of the emitter, if you connect emitter across this, no deflection will be shown by the emitter, no current will be recorded by the emitter. It is clear? When the Wheatstone bridge is in the balanced state, then P upon Q equals to R upon S, that is this point and this point will have the same potential. Then its second part, draw labeled circuit diagram of a potentiometer to measure the internal resistance of the cell. So already I have drawn here. It's clear. This is the potentiometer wire AB. This is the potentiometer wire AB. Now from the ends of the wire there are two circuits. One is the main circuit in which a battery is connected. Here this is a battery is connected. It is clear. Then a key is connected. Then an emitter is connected here. It's clear. This. Then there is an auxiliary circuit. Auxiliary circuit, here you have to determine the internal resistance of the cell. So auxiliary circuit will be connected in this side. We will connect the cell here. You can see here. This is the cell is connected. Then with the help of a plug key K1, we will connect the with the help of plug key K1 we will connect the resistance box. Now what will you do? And this is the galvanometer and this is the jockey. First you connect the galvanometer with the cell. Connect the galvanometer with the cell, and here this is also completed. It's clear. This is connected directly. Instead of connecting this way, we will connect it directly. It's clear. You can see here. Now what will you do? Firstly you will keep key K1 open. Key K1 open is open. When key K1 is open, then what will happen? This circuit is incomplete because this is open. This is open, therefore this circuit will be incomplete. And EMF will get balanced across the potentiometer. Suppose the balancing length is L. So this balancing length is corresponding to EMF. EMF के corresponding balancing length is L. Now what will you do? Key K1 close. One close. And introduce a resistance R here. Introduce a resistance R in the RB and keep the key K1 close. So now what will happen? A current will flow through the circuit. Through the cell a current will flow. And when current will flow, then its potential difference, cell का potential difference क्या होगा? That will be balanced across the potentiometer wire. Let the balancing length is L dash. Now this balancing length L dash will be less than L, and it is corresponding to potential difference. When you have sorted the terminals of the cell by using the resistance R, then a current is flowing permanently through the cell. Therefore, now its potential difference will be balanced across the potentiometer. So, as we know that small r equals to what? Capital R E upon V minus 1. What is E? EMF of the cell. What is V? It is the terminal voltage of the cell when the terminals of cell are sorted by the resistance capital R. When the terminals of the cell are sorted by the resistance capital R. So, what will be E upon V from here? E के corresponding balancing length is L, V के corresponding balancing length is L dash. So what is E upon V? It is L upon L dash. So what is small r? Capital R L upon L dash minus 1. This. It's clear. So here you have to write the formula, write the working formula, make the diagram and write the working formula. It's clear. Now see the question number 20. This is based on the Kirchhoff's law. It's clear. So here you can see you have to find the values of I1 and I2. Now in order to apply the Kirchhoff's second law, Kirchhoff's voltage law, sigma IR equals to sigma E. We will take two loops. So one loop I am taking A in loop A B E F A. A B E F A means across the loop we are moving in this way, A B E F A. So if you see at the junction B, from the Kirchhoff's current law, I1 current is coming from this side and I2 current is coming from this side. So what will be the current through this? It will be I1 plus I2. It is clear? When this current reach at E, here, I2 current goes in this direction.
Use your fingerprints to unlock the device.
I2 goes in this direction and I1 goes in this direction. So what will be the current here? It will be I1. It is I1. What is current here? It will be I2. Current will be I2. So now this current is I2. So you can see here. So firstly we will apply the Kirchhoff's voltage law in this loop. So here we are traversing from A to B, A say B, then B to E, then E to F, and then F to E. Here in this loop IR we will get across R3 and across R1. और दोनों में हम किसके डायरेक्शन के क्रॉस, करंट की डायरेक्शन के क्रॉस ट्रैवल कर रहे हैं. हियर आल्सो वी आर गोइंग इन द डायरेक्शन ऑफ करंट and here also we are going in the direction of current. So I into R will be positive. What will be I into R across R3? What is I? कितनी I flow हो रही है R3 के क्रॉस? I1 plus I2 into what is the value of R3? It is 8. It is 8. Now this will be with positive sign. Why? Because we are traveling in the direction of current. Now you find out IR here. What will be IR here? It will be I is I1, R is 4. Across 4 ohm, IR will be equal to I1 into 4. Now there is no other IR in this loop. Now there are how many cells in this loop? In A, B, E, F, A, there is only one cell E1, and that is being crossed from where to where? Negative to positive. There is one more IR here also across E1, and that is also across the current, along the current. So that also you will take. What is the current through the cell? I1. Resistance is 2 ohm. So it will be 2 into I1. Now cell is being crossed from where to where? Negative terminal to positive. सेल को कहाँ से कहाँ? निगेटिव से पॉजिटिव क्रॉस कर रहे हैं. सो EMF will be plus. So when you will simplify 8I1 plus 4I1 plus 2I1, that is equals to 14I1. 8, 4, 12 to 14I1 plus 8I2 equals to 3. Now you take the another loop. The other loop is, we will take this C, B, E, D, C. In this we will apply the Kirchhoff's voltage law. C, B, E, T, C, this. So see here we will get IR across R3. IR across R3. You can see here. Here we will get IR across R3. It's clear. Across R3, and here we are traveling across in the direction of current. Then another IR we will get across R2. Here also traveling in the direction of current. Current की direction is this, and we are traveling in the same direction. Now across 1 ohm of the cell, here also in the direction of current. So what will be the IR? So across R3 it will be IR will be I is I1 plus I2. R is this. So this is I1 plus I2 into 8. Plus across this will be 7 I2. And across 1 ohm it will be 1 I2. Equals to, cell is being crossed from negative terminal to positive, so it will be equal to 4. So when you will simplify, 8I1, 8I2 plus 7I2, 15, 15 plus 1, 16I2 equals to 4. You solve them simultaneously, you will get the value of I1 and I2. Now see the next question. A potentiometer circuit is shown in the figure AB. Here it is, potentiometer circuit is given. AB is a uniform metallic wire having the length 2 meter and resistance 8 ohm. It is of 2 meter and its resistance is 8 ohm. E1, E2 have the EMF 4 volt, 1.5 volt. This is 4 volt, this is 1.5 volt. And their internal resistances are also written here, 1 ohm and 2 ohm. When the jockey J does not touch the wire AB, calculate the current flowing through the potentiometer wire. See here, when jockey is not touching to this, you have to find the current flowing through the potentiometer wire. So जब जॉकी नहीं टच कर रही है तो केवल इतना ही सर्किट है. इसका टोटल रेजिस्टेंस कितना हो जाएगा? सो सी हियर, सेल वाली ब्रांच इज ऑलवेज, ये सेल की ब्रांच है. नाउ दिस ब्रांच विल बी ऑलवेज इन सीरीज विद द रेस्ट ऑफ द सर्किट. So 8 ohm, 7 ohm, 1 ohm. What will be the total resistance? Total resistance will be 8 plus 1 plus 7, that is equals to 16 ohm. So what will be the current drawn? Current drawn equals to V upon R. V is given 4 volt. V is given 4 volt. 4 upon 16, that is 1 upon 4. 1 upon 4, that is 0.25 ampere. It is clear. Then you have to find the, so when the jockey J does not touch the wire, calculate the current. So that you have calculated 0.25 ampere. Now you have to find the potential gradient across AB. So what is potential gradient? Potential gradient, potential drop per unit length. So it will be equal to I into resistance of 1 meter length. So I is already you have calculated, it is 0.25. Now 2 meter का resistance is 8 ohm. So 1 meter का 4 ohm. So it will be 1 volt per meter. This is the potential gradient. Now the jockey J is made to touch with the wire AB at the point C. this jockey J is touched at this point, C point, such that the galvanometer shows no deflection. Calculate the length of AC. You have to calculate the length of AC. So see here, how will you find this length? Now this is also connected with this. This is balanced across this. So see here, in order to find this length, what will you do? Now this cell is also included across this. Now what will be V here? जितना V इसके क्रॉस है, that will be equal to across the AC, length AC. So see here, potential difference across length AC. It will be equal to, this is 1 point, here it is 2 ohm also. So you have to find the current also. It is clear. Now this is, now see here, at no deflection of galvanometer, potential difference across length AC equals to EMF of cell. What is the potential difference across the length AC? This is K into L. K is what? Potential gradient, which you have already calculated here. So it is K into L equals to 1.5. So what will be? K is 1 into L equals to 1.5. So what is L? L equals to 1.5 meter. It will be 1.5 meter. Now question 22, it is very simple. Here it will be equal to 4 upon R equals to this length upon this length. This length is how much? 40 centimeter. This length is 60 centimeter. So you will get the value of R, 4 upon R. This is the Wheatstone bridge. It is the question based on the Wheatstone bridge, meter bridge. Meter bridge is based on the principle of Wheatstone bridge. That is 40 upon 60. It is clear. Here it is given that the null point is found to be at 40 centimeter. So 22 ja 23 ja. So what will be R? 4 3 ja 12 upon 2, that is 6. It's clear. What change will you make in R to bring the null point to the midpoint of AB? So see here, suppose here we have connected one more resistance R dash. Then null point is at 50 centimeter mark. Now instead of 40, null point is here at 50 centimeter mark. Let the total resistance, what will be the total of these two? It will be R dash upon R plus R dash, because they are connected in parallel. Already you have calculated R is what? 6. So it will be equal to 6 R dash upon 6 plus R dash. Once again you apply the same. This resistance upon this resistance equals to this length equals to this length upon this length. But now this length will be what? 50. So see here, it will be 4 divided by already we have calculated this resistance equals to 6 R dash upon 6 plus R dash. So see here, when you will apply 4 upon this resistance, so 4 upon 6 r dash upon 6 plus r dash equals to this length upon this length, that is 50 upon equals to 1. So simplify, you cross multiply, it will be 6 r dash upon dash equals to 4. So on simplifying, what will be it? It will be equals to 6 r dash equals to 24 plus 4 r dash, that is 2 r dash equals to 24. So r dash equals to 12. Means in order to get the balancing length at 50 centimeter, you connect 12 ohm here in the parallel. So remaining question we will do in the next.